Good morning, everybody. Welcome to our class. Why don't you like maths? It's fun. It's interesting. I hope you guys did this Google Forms. You can copy it and fill it in. It will give us more information about your needs. I'm Arifa Hafaji. We're on grade 8 Natural Science and we're doing revision on mixtures. I hope you have an enjoyable lesson with me today. So by the end of this lesson, you'd learn more about mixtures and compounds. You'd be able to define a mixture, give examples of it, and distinguish between mixtures and pure substances. You'll also learn the different separation techniques of mixtures. Our lesson would be more on the separation techniques of mixtures. So a quick recap on what we learned this week, and we learned that pure substances can be classified as mixtures of substances, or they can be classified as pure substances. And these pure substances are either elements or compounds. Now, elements are all the atoms in an element. They are the same kind. That means that an atom cannot be changed into other elements by a physical or a chemical process. Elements can be built up of individual atoms or as bonded pairs of atoms. And these bonded pairs are called diatomic molecules. Now, when elements combine, they form compounds. Lucidi, yes, it is the latest revision for term 2. So yesterday I was going to show you how compounds can decompose. So if elements can decompose, they combine to form a compound, just like how two elements can form through heating or a chemical process. They form together to form a compound. They can also be broken down, and they can be broken down through a process called decomposition. And this is where it is decomposed by electrolysis. Now, electrolysis is where an electric current splits the compound back into its original form. So basically what happens is that when you apply heat, like here, if you look at the bottom at this battery is supplying energy. So when you apply energy to the cathode and the anode, the solution mix separates and the elements go back into its original form. So we say water can be decomposed, like this solution here is water. It basically decomposes into hydrogen and oxygen through the means of electrolysis. So you can see this is a plastic beaker. You have your battery, you have your rods, and you have a solution of water. So when you switch the battery on, this is your anode and this is your cathode. So when you put your battery on, then the water separates and it becomes oxygen and it becomes hydrogen. Now the thermal decomposition takes place when heat is used and to break down the compound, and it breaks it down into elements. So here's the test I wanted to give you yesterday, where I taught you what elements were, what compounds were, what mixtures of elements were, what mixtures of compounds, and mixtures of elements and compounds together. So you're going to look at the sheet here, and I want you to classify each of the atoms and molecules on the picture on the left-hand side, and you're going to categorize it into A, B, C, D, or E. So you can either raise your hand, my host will unmute you, or you can type it in the chat, and let's see if you guys are correct or not. So the 15 blocks, they contain a diagram, and it represents atoms and molecules. So block A, does this look like an element, a compound, a mixture of elements, a mixture of compounds, or a mixture of elements and compounds. Tyrese, electrolysis is the breaking down of compounds. Okay, so Lucidi and Favor said that it is a compound. Why is it a compound? B, you guys said B, but why do you think it would be a B? It could be correct. Why do you say it is B? Even Hawaii from his phone said it is a compound. Does it say compound? Look at it. It has two, because there's two or more elements. Well done, Favor. It is a compound because it is two or more elements together. I'm so glad you guys know this because it means you were paying attention yesterday. And also, Rafoli said there were two elements that were bonded together. So let's look at number 2. Is it an element, a compound, a mixture of elements, a mixture of compounds, or a mixture of elements and compounds? Okay, Favor said it's an element. Also, Tashida said it's element. Mikon said it's an element. And Zamkushle said it's an element. So it is C. C is a mixture of elements. Now let's look why it's a mixture of elements, because most of you said it's an element. So can you see that one is a black circle and one is a white transparent circle? So that means that there are two different types of elements together. It's not bonded together like how you find in number 1, sorry. It is separated, but so it is a mixture of elements. So can you see the difference between just one type of element and then there's two different types of elements? So the answer was C. And Sikelo said it was also C correctly, and somebody that's just a dash said it was C. So number 3, is it, what would it be? A, B, C, D, or E? Okay, Hawaii from his phone said it is E. Nanchlanchla said it's a mixture of compounds. The CD said mixture of compounds. So did Zamakushle, Favor also. So most of you agreed that it is D, and Mike said it was E. So let's see who's correct. Okay, Mike is correct because it is a mixture of elements and compounds. Now look here. These two here, remember I told you about diatomic molecules like oxygen. So it's a mixture of elements, and this is a compound. So it's a mixture of elements and compounds. So you see in your test when they give you pictures like this and they ask you to categorize how they can catch you. So you're going to be very careful when you look at things. So look at, oh, no, sorry, number 4. You all know now. Okay, sorry about that. So number 4, let's see. It is D. It is a mixture of compounds. So why it's a mixture of compounds? It's because there's two different types of compounds together. So let's see number 5. What do you think? Is it A, B, C, D, or E? Samakushla said A, so did Tyrese and Nikon, Rafoli, Mike, Anshlanshla, the CD. Favor said it's an element A, and Kashiza also said it's a element. Okay, and I think that you are all spot on. You get A plus for that. For Lucila said it's A as well, NQT and Hawaii. So let's see number 6. What's number 6? Okay, first Zamakushla said it was D, a mixture of compounds. Who's going to agree with her? Okay, Mike said it's a compound. Hawaii said it's D, it's a mixture. Nanshlanshla said it's E, a mixture of elements and compounds. Vuyusile said it's D. Dash said it's D. Mikon, Tanisha, Aviwe, and Rafoli said it is D. And the correct answer is B. It's a compound. So let's see who got it right. So we had compound was from Mike. Well done, Mike. Very good. Right, number 7. What is number 7? Is it A, B, C, D, or E? Who's going to go first? Okay, so it is A, Hawaii, Tanisha, NQT, dash, VUC, Nanshlanshla. Okay, Favor said it's a mixture of elements. VUC said it's A. The CD said it is C. Samakushle said it is C. And Preston said it is A. Right, let's see who is you said it is A. Why? Let's see why it is A, an element. Now, remember that word I told you to remember yesterday, diatomic. So it is two elements stuck together because it cannot exist on its own, like oxygen, nitrogen, hydrogen. So it is an element. Now, only when it's two, then it's going to be an element. But if it's three, or then it's not going to be an element. Okay, so two still makes it an element because we said nitrogen, oxygen, and chlorine and all those things, they hydrogen, they cannot exist on its own. It needs another atom to support it. So let's see 8, number 8. So Hawaii said it's C, Nanshlanshla E, the Hawaii said it's B, the Foley said it's E, Tashida, the CD, Favor, Aviwe, Vuyusile, Nikon, Tanisha. So there's unanimous. Everybody said it is E. Okay, and let's see. It is E. Well done. You guys are getting out, hey? So it is a mixture of elements and compounds. So the small transparent circle here and the black circle here are elements, and then you have the one that are 3, they are compounds. Right, so let's see number 9. Is it A, B, C, or D? Number 9, the CD, Tanisha, and Nanshlanshla said it is C. And who is going to agree with them? Preston said Tashida. Tyrese said it's C as well. Rafoli, well done. Hawaii said it's C. Okay, anybody else? Vuyusila said it is C. And the correct answer is C. Well done to you guys. Okay, now I'm going to get an A+ for our test. Number 10. What is it? Ishani, you want to speak? Samukushle, Lasidi, and Hawaii, Vuyusile, Aviwe, and NQ, Preston, and Shlanshla, Mekon. All you guys said it was E. Okay, and the correct answer is E. Well done. Okay, you guys are good now. Now, why it's E? Because you have your diatomic molecule here, that's your elements, and then you have your compound, which is the 3 circles there. So number 11. Is that D? Favor said it's D. Tashida. Nanshlanshla said it's B. NQT said it's D. Vuyusile said it's D. Lizanne said it's D. Dash D. Tanisha said it's D. Tyrese said it's D. And Rafoli Nanshlanshla said it's D. Zamakushle as well. And Mekon said it is B. And the correct answer is B. Well done to those that said it's B. So it is a compound. So we look at the picture and we see they're all exactly the same. So it is a compound. Number 12. Okay, Tyrese, well done. Hawaii, Zamakushle, NQT, Lasidi said it's B. Tashida said it's B. Preston Avi D. Vuyusila said it is E. Favor said it is C. So let's look at this. It is D. It is a mixture of compounds. Now, you can see that they are compounds, so it is a mixture of compounds. So it is, this one is a bit confusing, okay, because you have your compound here, which is B. Let's compare it to the compound there. And then you have your compound here. So the reason why they say this one is a mixture of compounds is probably because some have, look at this here. So where my cursor is, there's one black dot and two white dots. But here, there's two black dots and one white dot. That's why it is a mixture of compounds. So everybody that said it's D, excellent, well done to you. Number 13, what is that? E, Aviwe said, and Mike said it's D, Tanisha said it's D, MQTE, Tashida said it is D, Lucidi D, Favor B, Hawaii said it's E, Samkushle D, Preston, Erin, Mekon, Fuyusile, Tyrese, Lishan, and Dash said it is D. Okay, and the correct answer is D. Well done to you guys that said it is D. Okay, so you look at the compounds and they are different. Can you see the structure of each one? It is different. So let's look at number 14. What is number 14? Tashid, Hawaii said it's E, Tashida and Tanisha said it's D, NQT, Tyree said it's E, NQT, Aviwe, Lishan, Dash, Rafoli, Hawaii again said it's D, Lasidi and Favor said it's E, Nanshlanshla said it is D. And the correct answer is D. Okay, because it is a mixture of compounds. It's still compounds, there's no elements in it. And you see all the compounds are different from each other. So let's do number 15. What do you think that is? The CD said it is D, Tashida, Aviwe, Erin, Nanshlanshla, Vuyusile, Hawaii, Favor, Foley, Tyrese, Hawaii from a different phone, Zamakushle, and Tanisha, Ishani, all you guys said it is D, and you all are correct. So awesome. Well done. Okay, so I'm very proud of each and every one of you because you now learned how to differentiate between atoms, elements, and compounds. You see, when you first started, you were a little bit here and there, some of you, not all of you, and as you got from number 7, you all got very good at it. So well done. I'm very, very proud of you. Okay, can all give yourself a tap on the shoulder to say well done. So now we're going to go on to talk about mixtures. Now, a mixture consists of two or more substances that are mixed together, but not chemically combined. So that you get different types of mixtures. You get a mixture that can combine chemically, but then you get mixtures that do not combine chemically. And this lesson is more structured on mixtures that do not combine chemically. So they do not combine chemically, meaning that it is not going to form a new substance. They're still going to stay in its original form, but it's just going to be mixed together. Now, elements and compounds are mixed together to form mixtures. Now, when you take two elements and compound and you mix them through a chemical reaction, they also form mixtures. So you get two different types of mixtures. One where even though it's mixed together, they're not chemically combined. And then you get other ones that are chemically combined through chemical reactions. Now, the amount of substances can vary in a mixture. In some mixtures, we can recognize the difference between them and what they make and what makes up the mixture. And in some mixtures, it is not possible to differentiate between what makes the mixture and what doesn't make the mixture. Now you basically have different separation techniques to make mixtures. And these mixtures can be separated by physical means. Okay, physical means that you need to do it with your hand or some sort of a separation instrument. And separation by physical means is separation manually by hand or with an apparatus. Okay, so some mixtures are mixed. When they are mixed, they do not form new substances. Okay, just want to move that. The properties of a mixture are a combination of the mixtures and the substances that are mixed. Sometimes the different substances that are mixed can be distinguished. That means that you can tell it apart from each other. However, some mixtures, the different substances in the mixtures cannot be identified. Like for example, you're not able to tell the difference between the two. Who can give me an example of mixing something where you can, but you can't really tell the difference between mixing something? Anybody wants to try? Like it would be hard to tell apart if you had to mix it. Salt and sugar, very well done. Awesome. Okay, so mixing salt and sugar, awesome. It was Hawaii and Dash. Okay, Tyrese is looking for Levi. Also, oil and water, if you mix it, you can tell that apart because you remember that when I spoke to you about that earlier on in earlier lessons, I said that the oil floats on top of the water because it was the water was more dense than the oil. So we could say basically we can say sand and like beach sand and sugar. If you mix that, even though you can tell it slightly apart, but it will be difficult. But the salt and the sugar is an excellent idea where you're not going to be able to tell it apart. So substances in a mixture can be separated by separation techniques such as hand sorting, filtration, sieving, decanting, evaporation, crystallization, distillation, and chromatography. Sorry. So now these techniques, these separation techniques, I want you to learn very well. We're going to do it. I'm going to give it to you in our next slide again, and I'm going to define each term for you. Now, or I can ask you to define it, and then we can see if you know or don't know. Okay, so the properties of the substances in a mixture will determine the separation techniques that it's used. So basically, what that statement says is that depends on what properties you are using, then it or is mixed and you need to separate it. So these mixtures will different mixtures will use different separation techniques. Not all of them would be the same. Now let's test your knowledge to this test checkpoint. What is a characteristic of a mixture? Any characteristic that you know so far from what we discussed. Does anybody want to try? Okay, you're going to have to put it on the chat with everybody because I won't be chatting to anybody privately. That was quick. Does anybody want to try? Any characteristic of a mixture? Nobody. Okay, so let's see. We're going to say that the substance in a mixture do not chemically bond with each other and they can be mixed with different amounts. So this mixture that we're talking about that uses these separation techniques are not chemically bonded. Okay, Dash said it is a mix of substances on objects. Okay, so you mix different substances together where you can physically do it. Like for example, if you mix raisins with almonds, so you can get a mixture of raisins and almonds, which is very healthy to eat. Now, can you give me one separation technique of a mixture? Erin. Sieving, well done, Lasidi. Sieving is one separation technique. All you have to do is look above checkpoints. Hand sorting, well done, Erin. Hand sorting. Mike also said hand sorting, well done. Tanisha said evaporation. Hawaii said condensation. Aviwe said filtration. And Gift Favor Nanchlanchla said filtration. Mike said sieving. Okay, well done. I'm very happy that you guys are choosing different separation techniques. Even if you're just copying it for now from the top, I don't mind at all, because the fact that you are typing it out means that you are learning it. So Lucidi said distillation. I'll take a few more because I know there's more of you here. So we got sieving, filtration, distillation, we got hand sorting. Okay. There's also decanting, crystallization, and that I cannot say that word. Chromatography. Okay, chromatography. Now, those are the separation techniques that we learned. Okay, so it's filtration, sieving, decanting, evaporation, crystallization, distillation, and chromatography, and also hand sorting. Right. So now we have hand sorting. Hand sorting is basically when you use your hand to separate certain things. Like, for example, if you have almonds and raisins, a small quantity of it, you can actually physically separate it with your hand. Also, crayons. For example, you can also separate crayons with your hands if it's all mixed together. Right. Then we have filtration and sieving. Okay, so filtration and sieving, basically this is used to separate particles and fluid in a suspension. Filtration is the separation of fluids in a suspension, and sieving is particles that are too big to pass through the holes of a sieve are retained. So now, basically, if you're going to sieve, what can we sieve? Flour and sugar. Okay, not caster sugar and icing sugar, like let's say whole, like brown sugar, not even white sugar. Okay, and let's not use sugar. We'll say flour and rough salt. If we had to mix that together and we want to separate it, so we'll basically put the flour in our sieve and we'll shake the sieve against our hand, and you'll see the flour going down into the bowl, and then the rough salt stays on the sieve. So you can use that as a sieving, that is sieving as a separation technique. Now also, when people bake, they sift the flour. And the reason why they sift the flour is because they aerate the flour from being compact, because you know the flour is compact in its container. So when they aerate it, that means they make it loose and air combines with the flour. And this is what makes your cake a lot lighter to eat. And you can also do sieving by separating a liquid from a solid. Okay, that's also true because you're going to take, for example, I know this is not a very good example, but let me use it because this is how you normally, like you have a deep fryer. Okay, and if you use your deep fryer a lot, and if you don't wash it all the time, so what's going to happen is that you get that brownish residue at the bottom that actually forms into solids over time. So you take your strain and you pour the oil through the strain, and what happens is the cleaner oil falls down into the bottom, and then that comes the black grimish part that makes your oil dirty is separates. It forms a solid, and it comes on top onto the sieve. Okay, then we have evaporation and crystallization. Now that's why we always change the oil all the time, so you don't have that black and you don't see it. So you buy a smaller deep fryer so you can change your oil all the time. Okay, it's not healthy to use oil for a long time, especially with deep frying. So we have evaporation and crystallization. So evaporation is the conversion of liquid to gas. Okay, so that's water when it's heated becomes water vapor. And crystallization is basically the process of cooling something hot. So you get the concentrated solution of a substance, it becomes crystals. Okay, so when you cool something and it that was hot and it forms crystals, like you see in mines and stuff, you find there's crystals sticky, stalactites, I think that's what it's called. They stick down. Then we have decanting. Decanting is a process of separating a mixture by gravity, and this basically allows like sand and water. So basically, if you mix sand and water together, all you have to do is if you put it in a jug or a glass, you put the jug or the glass down after you've mixed it, and what happens is the sand settles down at the bottom. So this is decanting. It just the one that is heavier or more dense settles down at the bottom. So this is how this is the process of decanting. Then we have distillation. Now distillation is the act of purifying a liquid by a process of heating and cooling. So we have distillation. You can purify a liquid either by heating it, and you can actually purify a liquid by icing it as well. Like you would find water in the mountains, high up in the mountains. They actually pure water, and it's actually good for you to drink that, provided there's less humans around there, is because it is very cold up in the mountains there. So it kills all the germs. The coolness, it kills all the germs. So the water in the mountains is good for you to drink. So, Nanshlanshla wants to know, how do we separate water from hand sanitizer? So now I can research that for you and tell you, because and I'll let you know. And you can also Google it and find out, because it would you'd use like what the processes of maybe distillation, heating or cooling it, and see if you can, because basically hand sanitizer is made up of ethanol, alcohol, and water, and you can do it through electrolysis, because that's how you separate ethanol alcohol, through electrolysis. Okay, so chromatography is a technique used by passing it through a solution through a medium in which the components move at different rates. So I'll explain that again. You have chromatography basically means that you have a solution, and in that solution you have components, they move at different rates. That mean it's not moving all at the same time. So basically that's what chromatography is. It's like different elements and different substances are moving around in one solution, but at different rates. Okay, and that would be depending on the size of each particle or each element that is in that solution. So that's why it causes it to move at different rates. Now, mixtures are separated according to the properties of substances that make up the mixture. Like you have elements and compounds are often found mixed together. Now, none of the substances in a mixture are chemically bonded together, and the amount of each substance can vary in the mixture. So basically that's telling you that it's not constant, that you have to have like 500, okay, that's too much, 100 grams of raisins and 100 grams of almonds and mix it together. You can have 100 grams of raisins and 50 grams of almonds, and you can mix that together. So that it tells you that the amounts can vary. It doesn't have to be the same all the time. Because if you like almonds more, which is very nutritious for you, by the way, you should eat 7 almonds every day, because it increases your memory span. And it's very healthy, and it gives you protein as well. So now if you want to eat more almonds than raisins, raisins is something that gives you fiber, then you can just increase the amount of raisins that you want to put. Yes, Tyrese, it's real. Almonds increases your memory. Now, when substances are mixed, they do not form a new substance. But also you must eat, before I go that to that point, now when you eat almonds, you need to eat it in moderation. Anything you eat must be in moderation. You're not going to eat too much of it, just enough for your body so it needs what your body needs. Okay, so when substances are mixed, they do not form a new substance. Now, the properties of a mixture are a combination of the properties of the substances that are mixed. So now what does that mean? So we say when they are mixed, you don't get a new compound. You're not getting something new. You're not getting a new substance. It is just basically mixed, but it stays in its original form. Okay, like the almonds don't change to raisins and the raisins don't change to almonds, neither does it form something else. It's just mixed together. Then we have the properties of substances in a mixture will determine the separation techniques that is used. So this point is repeated for you to remember the different separation techniques. Okay, so if I can recall it quickly, it was sieving, hand sorting, chromatography, distillation, decanting, and I'm sure you remember the rest. Okay, let's see. Checkpoint. What is a characteristics of a mixture? I asked you this. Let's see if you remember. Name a characteristic of a mixture. We did it in the previous slide. Lucidity, thinking. Okay, so a substance when it is not chemically bonded. Okay, so the mixtures we're talking very well, Tashida. They are not chemically bonded. Well done. Okay, and then a separation technique is one of those I told you above. Filtration, sieving, decanting, evaporation. Okay, Flavor said it helps separate things. So these separation techniques, well done. It helps separating objects or substances. Okay, so now there are not many pure substances in our life every day, and most of these substances around us are mixtures of elements and compounds. And remember I told you that in the periodic table there were more natural elements in the periodic table as opposed to man-made elements. Now, examples of mixtures include the air that we breathe, like for example, oxygen, nitrogen, carbon dioxide. You get fizzy cool drinks as well. These cool drinks are carbonized. So it has those bubbles like the Coke or your raspberry or cream soda. These are carbonated drinks. Even your water, the sparkling water, not the still one, they induced carbon into it. And then you also have steel. Steel has iron and carbon in it. Then if we had to mix water and sugar in a glass, now it forms a sugar solution. The water and the sugar, they do not react chemically to form a new substance. It is just called now sugar water. So it didn't form something new even though you mixed it. It just became sugar water. And it's also very difficult to separate sugar water as well. So the sugar molecules are mixed with the water by moving between the water molecules. Now, sugar water mixture has the properties of water because it can be poured into another glass, and the mixture also has the properties of sugar because it tastes sweet. And then we can use any proportion of sugar and water. The more sugar you use, the sweeter it's going to drink. But you must not have too much of sugar because it affects your blood sugar level. Okay, Tyrese, that is a reminder. Okay, now we cannot see the sugar in the mixture, but we know that it is there. Thank you, Tyrese, for the reminder. And then when we make a mixture of water and sand, then we're going to mix sand and water, and we can see the sand and the water because it's decanted. You'll see the sand at the bottom of the water. So when an element or a compound in a mixture is needed, in its pure form, it can be separated. Okay. Then we have the separation methods that we use are different depending on the substances that are mixed. So you must learn those separation techniques I taught you. You must learn it very well. Also learn the definition of it. Now, an example of a mixture is peanuts and raisins. Now, when the particles are big enough, you can use hand sorting to separate it. So you're not going to use like a sieve to separate the peanuts and the raisins. You'll use your hands to separate it. Filtration and sieving can be used to separate the sand and water and the mixture because the sand is visible. Now, water can move through the sieve or the filter paper and the sand will stay behind. So you're going to filter the water through the filter paper. Now, to separate sugar from the water, the mixture can be left in the sun. So the water will evaporate and then you'll get the sugar crystals that will be left behind in the container. And if you mixed oil and vinegar, the oil and vinegar can be separated by decanting because the oil floats on top of the vinegar. Also, if you just mixed sand and water and you don't want to sieve it, but you just want to see what happens, then it will decant and it will stay at the bottom of the water. Okay, so I'm going to do some checkpoints here. This is the end of mixtures, the section on mixtures. So name the difference in the separation of compounds and mixtures. Now the elements of a compound are separated by adding energy, such as heat and electricity, while the substance in a mixture are separated by physical means. That means you separate and the separation techniques. Now, why do we separate sugar and water? Through sieving. Now the sugar is not visible, so it will move through the water and in the sieve and the filter. So you're not going to see the sugar in the water. Okay, so you cannot actually separate the sugar water through a sieve or through filtering it because it has dissolved. But if you leave it outside in the sun, it will evaporate and form sugar crystals. Okay, so your next section that you're going to do is the particle model of matter, which we did discuss as well, but I don't have time to actually do it. So your teacher next week is going to do it with you. But I'm going to summarize the separation techniques, which is hand sorting, filtration and sieving, evaporation and crystallization, decanting, distillation, and chromatography. So the information for this lesson was derived from ciavela.com and nect.org. And I'd like to tell you guys that today is going to be my last lesson teaching you natural science, grade 8. And has truly been a pleasure to have taught every one of you. I will miss all of you, and I will actually miss teaching this subject because I really love it. And I wish every one of you success and happiness in your life. The reason why I can't teach it anymore is because I have to go back to school on Monday, and they've scheduled me to teach at the same time as this lesson. So you will have a new teacher next year. Not next year, sorry, next week. And I'm going to miss you guys very, very much. I'm going because I'm a teacher. I'm old, unfortunately. I'm not young like you that gets to stay at home. So I wish all of you a happy and safe time. And remember, happiness is a state of mind. So you can always be happy if you condition yourself to be happy. So it's been a pleasure teaching you. Thank you, Erin, for those kind words, and to Sheila and Nanshlanshla. Bye, everybody. Have a lovely weekend and enjoy the rest of your time. Also, remember to study. And you have my email address if you need any questions or you don't understand anything. You're welcome about natural science. You're welcome to contact me. If you want my slides as well, I will send it to you. It's ahafsea@gmail.com. And you will pass, all of you will pass. Thank you for that. That is very kind of you to say that I'm the reason that you pass. I really appreciate that. I shall take that with me. Bye, everybody. Thank you, Helen. It has been a pleasure teaching you as well. Okay, have a lovely weekend. I'll also miss you, Ishani. Thank you, Favor. Bye, Tyrese. Bye, we'll see you later.